Okay, so here with 8.7, we are working with and taking a look at proportions. So we have our general form that we're going to see proportions written out in, and we'll solve a couple examples with these as well, and then go into some story problems with these. So proportions, it's an equation of the form A over B is equal to C over D. And we are assuming in these instances that B is not equal to 0 and D is not equal to 0. Main reason for that, we cannot divide by 0 and get real answers. So we shouldn't have to worry about that with these types of problems as we're working through them. So while we have a problem written out this way, one of the ways that we see it read out, if we're going to be reading this out from English to algebra or vice versa, we read it as A is to B, as C is to D. So if we see this written out, this is what it's going to translate into. This is one of the ways it translates. Now we can and will see in our story problems that we have down below here, this is not the only way that we write out proportions, but this is how you would write them out in the very, very generalized sense like we have here. So I want to link that English to algebra stuff here because when we get to story problems, there's going to be a lot more of that. So once we have a proportion set up for ourselves or anything like this, we're going to solve the equations for the remaining unknown using our previously learned methods. So everything that we've learned up to this point in time with solving and working with fractions, you can absolutely apply here. One of the best ones, one of the quickest ones we have here is cross multiplication. It speeds up the process quite a bit. So our cross multiplication states that you would take the numerator of the first fraction and multiply it with the denominator of the second fraction. And you get a result. So we get AD on one side. Then you would take the denominator of the first fraction and multiply it with the numerator of the second fraction. So we kind of cross over here. That's where it gets its name for the cross multiplication. And we would put that result on the right side of our equation that we have over here. So this is an extraordinarily handy tool. It speeds up the process quite a bit when we are working with proportions. Now the very, very big warning, I'd circle, highlight, stars, whatever around this thing, very important here. Cross multiplication only works when a fraction is equal to a fraction. If either side of the equation has any other terms, it will not work. So it's a quick glance to the examples that we have here. Our first problem is a fraction equals a fraction. I can cross multiply here. Second problem, fraction equals a fraction. The denominator of this fraction does admittedly look a bit gross because it's got an x plus 4 in there, but it is all encompassed inside of one single fraction. So I could cross multiply here as well. Looking at example 3, I have a fraction and another term over here. I'm adding something here, which means I have a variable term and a constant term. So based on that alone, I cannot cross multiply. I could combine these things on the left-hand side to become a single fraction and then cross multiply, but as it's currently written right now, I cannot cross multiply and get the correct answer. I need to do something with this other term here before I can do any kind of cross multiplication whatsoever. And then our fourth example, same thing. I have a fraction and another term. I have a fraction and another term, so I cannot use cross multiplication here until I get everything down to be a single fraction equals a single fraction. There's multiple options you can take to make that happen in our fourth example and the third example. Lots of options at your disposal. Lots of ways you could go about doing that. So again, we can rewrite everything as a single fraction and then cross multiply. But if we do not start with that in our initial problem, you cannot just jump to using cross multiplication. A lot of people try and do this, and a lot of people lose a lot of points because of that. So I'll go through examples with these and show you, or both of these examples, and show you guys some ways that you could rewrite these to be a single fraction. But again, there are multiple ways you could do that. So we're going to go through these 4 examples. So I'm referencing those over on the blackboard. this is the set that I am working with, and we'll get to story problems here shortly. So jumping over to the whiteboard, move us down here. There we go. Those are all examples there. So let's separate this out. Try and keep our work somewhat organized and put together. Okay, so our first example that we were working with, proportions. So we were given 87 over n is equal to 48 over 16. So again, given a proportion, we're told to solve this proportion for the unknown variable. And because I have a fraction equals a fraction, we can use cross multiplication here. So the numerator of one times the denominator of the other, and then the denominator of the first one times the numerator of the other. And I would recommend when you are doing this, write these out as multiplying first. A lot of people try and write it out and multiply and do some division all at once, and when we rush our process, we can have errors show up. So on the left side, we have 87 times 16. I don't know what that is off the top of my head, so off screen, I'm using a calculator. You can multiply those together. When we do that, we get 1,392 is equal to 48n. Again, you guys are more than welcome. I highly recommend use your calculators for those big number crunches like that, because I don't know what those numbers are. I don't expect you guys to be able to do the mental math for that, so you're good there. And then I don't want 48n, I just want n, so divide both sides by 48. Write it out for yourself. But then off to the side, off screen, I'm using a calculator again. Dividing both sides by 48, I get 29 is equal to n. So I have a final answer right there. So again, this cross multiplication at the very beginning, very, very handy, very, very useful. Speeds up the process quite a bit. So our second example, we were given 12 divided by x is equal to 36 over x plus 4. Better 36 there, did not like that 3. There we go. So again, in this instance that we have here, we have a fraction equals a fraction. The denominator of the fraction on the right-hand side doesn't entirely look like the one that we had in our previous example. It's not just a number, it's got a variable and it's got terms in there. So it looks a bit weird. However, again, it is encompassed all within one single fraction, which means overall I still have a fraction equals a fraction. So I can still cross multiply with this example. So I'm writing that out for myself. And again, in your next line of work, and this is where I highly recommend you write this out, because this is a part where a lot of people rush themselves and get wrong answers here. So I have the numerator of the first fraction times the denominator of the second on the left-hand side is equal to the denominator of the first fraction times the numerator of the second fraction on the right-hand side. And again, now the reason I emphasize that you guys write this out, especially like what we have here on the left-hand side, is from here, we need to use the distributive property to put 12 through to both values inside here. And what a lot of people do, this is where errors show up, is they say, oh, I have 12 times x minus 4. Okay, so I multiply those together and I'm going to get 12x plus 4. And it's actually not going to be that. It's going to be 12x plus 48, because that 12 needs to go through and multiply to both of those terms inside there. It's a very common error that people make because they do not show the work, because they are unwilling to write an extra line of work down to keep everything in line for themselves. So take that one extra line to write that out, and then now we can solve this thing out from here. I have x's on both sides. I'm going to get rid of the 12x on the left side because it's the smaller value. So it cancels over there. We get 48 is equal to 24x. Divide both sides by 24. Two is equal to x, and again, just rewriting that sort of variables on the left-hand side. X is equal to 2, and we're good. So these are our two examples where we have proportions showing up, and we are able to just use cross multiplication and find our answer there. So go on to our third example where we are not able to, at the very beginning, use cross multiplication. Oops, plus 1 is equal to 9/4. So again, we have a couple options on how we can go about doing this if we want to. But if our goal is to use cross multiplication to solve this thing, then we need a fraction equals a fraction. And we have two ways we can do that. We can combine everything on the left side of the equal sign to be a single fraction, which is an option. Or we can combine that 1 on the left-hand side, combine this 1, with the 9/4 on the right-hand side. So we can move that constant over to the right, and then combine those numbers together over there. Either option works. It does not matter which one you choose. You just need to choose one and move forward with it. So for this problem, we'll show the other way with the next one that we have. I'm going to move this 1 over to the other side and then combine things together over there. So I'm going to subtract 1 from both sides. Let's get a better 4 there. There we go. So I have 9/4 minus 1. Remember that when we are adding or subtracting fractions together, we need to find a common denominator. The lowest common denominator between 9/4 and 1 is 4. So I can rewrite that 1 to be a minus 4/4. When I combine those together, I'm getting y/4 is equal to, if I could write better today, that'd be fantastic. Equal to 5/4. There we go. Much nicer. So now from here, I have a fraction equals a fraction. I can cross multiply, get my answer. So I'm getting 4y is equal to 5 times 4. 4y is equal to 20. Divide both sides by 4. And we get y is equal to 5. And you may be saying and noticing in here, in this line, saying, well, these things, the denominators are basically identical. Wouldn't this make the numerators pretty much identical here, since I just have an unknown and the thing it's equivalent to is just 5? In this instance, because I have nothing else being added to this y, so I don't have like a y plus 1 or a y minus 7 or something like that in there, yeah, we can kind of just jump to our answer from this step in this extraordinarily particular scenario. Otherwise, I would recommend going through the process like we have here. Okay. So this is an instance where Again, we cannot cross multiply at the beginning. We have to do some setup work if we want to do that to get it to be a fraction equals a fraction like we have here to cross multiply. And this is just one of the ways that we can do it. We can move everything to one side and combine it and do it like that. Now let's go to our fourth example. We've got even more going on with this thing. So we have a plus 1 over 3 minus 2 is equal to a over 6 plus 1. Better a. It's not a 9. There we go. So in our previous example, we worked with putting everything onto one side of the equation and then combining it together to be a single fraction. Or all the constants on one side and combine them to be a single fraction, I should say. So in this instance, we're going to do it a slightly different way. And again, if you're remembering back to, I believe it was 2.5, 2.5, I think it was, where we were working with equations with fractions showing up in them. And you might be thinking, well, couldn't I multiply this entire thing through by the lowest common denominator, get rid of the fractions entirely and not have to worry about this? Yes, you can. That is another option that is available to you. I just want to give you guys another tool that you can use, should you choose to go through and solve these things. On the test, it will be your call on how you want to go through and solve them. But I do want to give you guys as many options as you can, because I do think there is some merit to seeing another way of solving these things. So let's look at the left side of this equation first. Our goal for right now, we're going to look at the left-hand side. I want to combine everything together to be one single fraction. The only way, again, we can combine fractions together is to have a lowest common denominator. So I need to rewrite one or both of these fractions to have a common denominator, have that least common denominator. Remember that any whole number that's just written to us that does not look like it's written as a fraction is implied to have a denominator of 1. So the lowest common denominator on the left-hand side of the equation between 3 and 1 is going to be 3. So I need to rewrite that minus 2 to have a denominator of 3 and be an equivalent fraction. I'm just going to make it a 6 over 3. So now the left-hand side, they both have the same denominator, and now I can combine the numerators together. So I have a plus 1 minus 6 all over 3. I get a minus 5 over 3 showing up. So everything now on the left-hand side has just been combined together to be a single fraction. Carry the equal sign down now. And now I'm going to work just with the right-hand side. I'm doing the exact same thing, got some different numbers, the exact same process. That 1 written on the right-hand side is implied to have a denominator of 1 below it. And again, I need to find the lowest common denominator between those two fractions to be able to add them together. And that's going to be 6. So I need to rewrite that plus 1 off to the end to have a denominator of 6. So it's going to become 6 over 6. Now that the denominators are the same, I can combine the numerators together. I get a plus 6 all over 6. I can't do anything else to that right side of the problem as it's written, so I can't combine anything else there. That's fine. We're just going to bring it down as it is, so everything is lined up right there. So now I have a fraction equals a fraction, and now I can cross multiply and solve this thing out. And again, when you are doing this, write it out for yourself of the denominator. Oops. What is multiplying together? And now from here, we're just using the distributive property. We're going through this thing just like we did with the previous ones, or just like we've done with previous homework or previous problems. Nothing new, nothing spectacular with that. I'm subtracting 3a from both sides. I want to get rid of the smaller variable on both sides. And then I need to get the variable term all by itself, so I'm going to be adding 30 to both sides. Canceled there. I'm dividing both sides by 3. I do not want 3a, I just want a. 3's cancel. Get a is equal to, off the top of my head, I think it's 16. And we have our final answer there. So again, I've gotten the question about this in the past, so I'm again just reiterating this now. I get the one of, well, looking at this thing, we already learned in 2.5 that we can get rid of these fractions entirely by multiplying by the lowest common denominator of all of the original fractions in the problem. And then we don't have to worry about any of this other stuff down below here. And that is 100% correct. Again, I'm just giving you guys another option on how you could go through and solve these things if you have fractions showing up in your original problem, if you want to use cross multiplication to go through and solve them using these two methods. So just another option that is available to you. It's your choice on which one or which method you would like to use. I am kind of indifferent on that front. There are advantages to each of them. There's disadvantages to each of them. It's your choice on which one you would like to use. Okay, so we're going to jump back to our notes and we're going to take a look at story problems. Everyone's favorite thing in the whole wide world, I know. But they're not going to go away, and we're going to have them for the rest of this quarter. So we do want some strategies with them. So for story problems, if you are taking a look at the textbook, I'd recommend taking a look at page 972 for a proposed strategy with them. It's kind of a generalized strategy with story problems, whether it be for these or otherwise, but it's a generalized one. But unfortunately, the reality is there is no singular, here's how you solve all story problems in math strategy. It sadly does not exist. I wish I could give you guys one, but there isn't one. So we do have to kind of make our own and adapt and work with those on a case-by-case basis and have a generalized strategy with these things. So when we are working with proportions, the best recommendation that I have for you guys, and we'll go through this with these two examples as well, just so you guys can see that. Set up a fraction equals a fraction, no variables written in. Label the numerator and denominator of the fractions for a specific unit. Especially with story problems and proportions, you absolutely must be given some kind of units that we're working with. And more often than not, yeah, we're going to be given that in some way, shape, or form in the problem. Or maybe we can look up some information about those specific units as necessary from the problem. It does not matter when you're labeling these things which unit goes in the numerator and which unit goes in the denominator. Just assign them and then be consistent through the rest of the problem. And I cannot emphasize this step enough as well. Do not rush the setup step for story problems. The setup is crucial to be able to do everything, whether it be for these specific story problems, whether it be story problems in the next chapter or otherwise. The setup is the thing that is going to make or break your entire story problem. If you do not do that properly, or if you try and just fly through it at a really fast pace and you get the wrong answer, it's probably an error in your setup. It's not always the case, but more often than not, that's where I find people make mistakes with these. Setup is absolutely crucial all of these problems. So let's take a look at these two examples that we have here. And again, we'll jump over to our Blackboard and go through and actually write some of these out. So solve the following. We're told to round the answer to 2 decimal places. Okay. When looking at a map, 1.5 inches is equivalent to 5.5 miles. So how many miles is 9 inches equivalent to? And our second question is asking us, how many inches is 32 miles equivalent to? So we have some information about the map, and we have some information that we are trying to solve for in a first scenario and our second scenario. So again, our setup is crucial with this. It's going to make or break both of these problems that we are solving for. So these are the problems that we are referencing. I'm going to jump us over to our whiteboard, but I'll read these problems off again as we're going through and solving them. So we'll move us over here. Oops. Come on, let me write with, there we go. So here we have our story problem that we are working with, and we'll work with our first scenario. So again, I'm rereading this off from the other page so we have an idea of what we're working with here. When looking at a map, 1.5 inches is equivalent to 5.5 miles. First problem, how many miles is 9 inches equivalent to? How many miles are 9 inches equivalent to? So we are working with a proportion problem. So I've got a proportion showing up here. Start with fraction equals fractions. We've got our fraction bars written out for ourselves. Leave them blank for now. That's fine. The next thing we want to do, what are the 2 units that we have been given? Are we given feet? Are we given meters? Are we given gallons? Anything like that? And in this problem, we have been given inches and we have been given miles. So we need to label either the numerator is going to be inches or miles, and the denominator is going to be the opposite of that. It does not matter which one you label in which spot of the fraction. Just choose one to be in one of the spots, choose the other one to be in the other spot, and we stay consistent with that the entire way through. So I'm going to choose to have inches be in the numerator spot, so I'm just going to off to the side here. Inches up top. And then I'm going to put miles down below. And now we can start filling this proportion in with numbers, variables, things like that as we need to. So we'll reiterate the problem. When looking at a map, 1.5 inches is equivalent to 5.5 miles. How many miles is 9 inches equivalent to? So we have 2 scenarios here. We have the original scenario, which tells us the ratio between inches and miles. The 1.5 inches is equivalent to 5.5 miles. So I am going to write that in on the left side of my equal sign in the corresponding spot with its corresponding units. So 1.5 inches is equivalent to 5.5 miles. And now for the specific scenario, how many miles is 9 inches equivalent to? So I have been given 9 inches. I do not know what miles is or what miles represents. So you could write that in as an unknown. You could put in an X, you could put in a Y. I am going to use M to represent miles, but you can use any variable there. So now I have this thing set up, and I can cross multiply, get to the answer. So 1.5 times M is equal to 9 times 5.5. Goes up here a little bit further. There we go. And then I don't know what 5.5 times 9 is, so I'm just going to apply the calculator for that. So just doing that off screen, you can use your calculator for that as well. And we're getting 49.5 for that. Now I don't want 1.5 m, I just want m, so I'm dividing both sides by 1.5. I'm getting m is equal to, and then apply your calculator again, because I don't know what the number is off the top of my head. I don't expect you guys to. I'm getting 33. So 9 inches is equivalent to 33 miles. We have our answer there. Taking a look at the second part of that story problem we have there, we are being asked how many inches is 32 miles equivalent to? Well, again, we're working with a very similar problem. We just have a different unknown. So get in the habit of fraction equals a fraction. Label which unit is going in which spot. For the sake of showing it, I'm going to reverse where the units are for this example. It doesn't matter if you want to keep yours the exact same. I just want to show this as you can reverse these things and it will work all the same. So if you want to stay consistent, like we did in the first example, inches on top, miles down below, go for it. You're more than welcome to do so. Nothing wrong with that. So again, the original problem tells us when looking at a map, 1.5 inches is equivalent to 5.5 miles. So make sure you have your numbers lining up with their appropriate units. And then for this specific problem, we're being asked how many inches is 32 miles equivalent to. So I know the amount of miles that I have showing up. Inches is unknown. I don't want to use I because that's already a very special thing we have with math. So I'm just going to use X for this one. And now I have a fraction equals a fraction, cross multiply, and then we're solving this thing out from here. Now it becomes super mechanical, just like we did with our previous problems. And the only variability that's going to be showing up with this is what are the numbers going to be as we multiply things out. And again, stuff like this, use your calculator. So I'm doing off screen because I don't know what these numbers are. Some of these numbers are off the top of my head. And I don't expect you guys to. So 48 divided by 5.5, again, still don't know that. Oof, again, kind of a gross answer there. So I'm getting 8.727272, and it goes on like that forever. Now in this story problem, we have been told round your answers to 2 decimal places. So I'm going to round here, which means I need to look to the variable or the digit directly to its right. If that's 5 or more, I round up, which it is. So I'm going to get an approximate answer of 8.73 inches because of rounding. So always make sure that when you are rounding your answers, you do not do any rounding to that decimal place we've been specified until the very, very, very end of the problem like we do here. And I've already gotten a couple of emails from some people saying that they went through a problem and they got an answer, but the WAMAP said it was wrong, and as it turns out, WAMAP didn't specify to write the answer as a fraction or as a decimal. So in that regard, when you are going through the homework, just because you get a fraction answer, just because you get a decimal answer, and it says, and WAMAP says it's wrong, does not inherently mean it's wrong. It may very well be the case that you just need to write it in that alternate form, and you can use your calculator to do that for you. On the test, I'll be doing my best to specify to you guys round your answer to the nearest blah many decimal places, or leave your answer as a fully reduced fraction, something to that effect, so you guys do not have to guess at what form I want the final answer written in. I don't like that that shows up on the homework. I don't like it when people do that or instructors do that on tests. I don't think it's fair to you guys to have to guess at that. So I'll be making that as abundantly clear as I possibly can. You guys just need to make sure you are going through and reading the problems to answer it in that specific form that I'm looking for. Okay. So this is everything for the 8.7 material. Again, it's kind of our story problems. It's just an example of them. You can find, and you will find, that there are other ones that are going to be showing up on the homework and otherwise. But again, just a starting point with these. And again, make sure with the cross multiplication, you can only use cross multiplication when you have a fraction equals a fraction. If anything else shows up in there, you cannot use cross multiplication at all. Okay. So with that, I'll end the recording here and take any questions that you guys have.